Today we're going to be looking at the laws of exponents. Don't break the law, right? The laws of exponents. And here's what they are. To review, because supposedly you know this. This is a topic that you usually get before algebra. If you haven't gotten it in your pre-algebra classes, then you're getting it now for the first time, and here's what they are. So if you are multiplying powers with the same base, you add the bases. Now let's just, what? Let's do an example. Suppose I have 5 to the third power times 5 to the fourth power. So why am I adding these numbers? Let's think about what these are. You're really trying to find out how many factors of 5. Because what is 5 to the third power? What does that mean? 5 times 5 times 5. This says you have 3 factors of 5. And what do I mean by factors? What does that word factors mean? Multiply. Things you want multiplying. Okay, so that's what that is. This is how many factors of 5? 4 factors of 5. And I'm multiplying, so everything is being multiplied, right?
Yeah.
So how many factors of 5 do I have now?
7.
So does it make sense when you're multiplying numbers with the same base that you are adding those exponents? And let me just review what the words mean. This whole thing is called the power, right? The big number, right, that's your base, the thing that you're taking factors of. The exponent is the little thing up here to the right. That means that you are taking that many factors, right? So that's a power. So when you multiply powers with the same base, add those exponents. And with these rules, I'm always like, don't memorize. Just remember what you're doing. 3 factors of 5 times 4 factors of 5 will give you 7 factors of 5. And if you think of it that way, it's less a memorization rule. Another rule that we have is when you divide powers. So you're going to subtract the exponents. So a to the m over a to the n, right, dividing, is a to the n minus n. But why is it subtracted? Let's do the same thing. Maybe this is 6 to the fourth over 6 to the second power, right? Well, what is that? That's 4 factors of 6 over 2 factors of 6, right? And 6 over 6, that's 1. 6 over 6, that's 1. You're left with 2 factors of 6. 4 minus 2. So again, if you're just strictly memorizing, it doesn't always make a lot of sense. But if you know why we're doing it, maybe you can remember it better. That's what I do. Okay, so that's multiplying powers, dividing powers. We can also raise a power to a power. So if you have a to the nth power, that whole thing raised to the nth power, you multiply. Well, again, let's use an example. What if it's 2 to the third power raised to the fourth power? I'm saying that's going to be 2 to the 12th power. But why? Well, that's 2 to the third times 2 to the third times 2 to the third. Isn't it? 4 powers of 2 to the third, or 4 factors rather of 2 to the third. And now I'm back to my add rule, right? 3 factors of 2, 3 more factors of 2, 3 more factors of 2, 3 more. How many factors of 2 do I have? 12 of them. That's why I'm multiplying. Yes, ma'am?
Why wouldn't you just multiply?
Why wouldn't I do what?
Why wouldn't you just multiply this?
Like 2 to the third is 6?
Yeah.
Because it's it. Think about what this is. Now, there are a lot of things you're going to want to do, and I'm glad you're bringing that up. Some people, when they see 2 to the third, they say 6. Is that what it is?
No.
Why not?
Is it generally wrong?
Because what is it? I have 3 factors of 2. 3 factors of 2. 2 times 2 is 4 times 2 is 8. Why don't we just multiply the 5 times the 5 here, right? Why don't we do that? Because that's not what we're doing. We're doing 3 factors of 5 times 4 more factors. 25, it doesn't work. 25 to the 7th is not the same as 5 to the 7th. So really, when you're working with these kinds of exponents, you're like, how many factors of do I have now? Yes?
So like the multiplying thing is like 5 times 5 with the exponent rule. Find out what that is.
Sure.
And then find out that is.
Sure. Well, what if that was like a 13 and that was a 400? You know, it starts getting harder. So, or what if it's not a 5? What if it's an x? Like, what if you have an x squared times an x to the 5th? And what's that? all together? 7. That's why you're adding exponents. Okay, so far, we multiply, you add exponents. Divide, you subtract. You can keep these little pictures in mind. If you're raising a power to a power, you are multiplying them. And then raising a product or a quotient to a power. Raise all chapters to that. Let me just erase this real quick. Okay, so what's what? Okay, this is saying if you have AB, so you're multiplying stuff and you're raising the whole thing to the nth power. I'm saying it's kind of like distribution, but it's not. The m goes with the a and the m goes with the d. Why? Well, let's use an example. Let's say it was, I'm going to use xy to the third power, say. Well, what does that mean? It says you have 3 factors of xy. So you have xy times xy times xy. You with me so far? Yeah. Okay. Now, what does that mean, xy? I don't see an operation there, but what is the operation? Yeah, there's multiplication between all these, isn't it? Everything is being multiplied. We have something called the commutative property of multiplication. Let's just change the order, right? So can I change this to be all the x's together, followed by all the y's together? And then what's that? X to the third, y to the third. Once again, how many factors of x? 3. How many factors of y? 3. So that 3 goes to both of them. See what's going on there? Now the same thing with dividing. If you have a fraction, that's the same as x over y times x over y times x over y. Right? You have 5 factors of x over y, right? Now that means you with me? Okay, so what is that? How do you multiply fractions? You multiply numerators. So how many factors of x up top? And how many factors of y in the bottom? That's y. So again, like I hate giving stuff to memorize without knowing where it's coming from. I can't remember, but if I see this, I know it's coming from. I can figure it again. A little bit trickier though. What if it's x squared y cubed whole thing, 4th power? Well, I can. That would be x squared to the 4th power and y cubed to the 4th power. Power to a power, x to the 8th, multiply, power to a power, y to the 12th. So it can get complicated, but always go back to these very, very simple rules. You kind of follow this so well. Good, good, good. My tips that I have, and I have it on your notes here, if you forget the rules, recreate using these simple examples. That is saying don't try to memorize because it's confusing if you don't know where it's coming from. If you can't remember, oh, is this the one where I multiply them? Or is this the one where I add them? So, like, if I give you a hard one, x, y, times x, 10, y, not that it's so hard, but you're like, what do I do here? You're multiplying. So how many factors of x? X to the 11th. And how are you going to remember that? Do a simple example. What's 2 to the 3rd power times 2 to the 4th power? Remember, that's 3 factors of 2 times 4 factors of 2. That's going to be 7. Oh, okay, I add. So that's what I mean by come up with a simple example. You can't remember the rules. This is kind of an important point here. When raising a product to a power, be careful with negative signs. -2 to the 3rd power. What is that? -2 times -2 times -2, right? What's a negative times a negative? Times a negative? What is -2 to the 4th power? Well, let's see, -2. Right? 4 factors of -2. Negative times negative is positive. Positive times negative is negative. Negative times negative is positive. So this little tip is saying, if you are raising a negative number to an odd number, you will get a negative number. And if you're raising a negative number to an even power, you will get an even power. Does that make sense? Yes. Think about it. What is like -2 to the 21st power? I don't want to have to write that 21 times, right? Is this going to be a positive or negative number? Negative. A negative number. it's the same as -2 to the 21st. Because you do all this and make it negative. That's what that means. Yes?
Okay, so if the number doesn't have an exponent at all, and then
Like this one?
no, like and it's just a regular number.
This is a regular 2. Is that a regular number?
Yeah, like would it be
What's its secret exponent? How many factors of 2 are here? So you can almost picture an exponent as anything. I don't know what your, let me finish your question.
zero.
Okay. Awesome question. Hold that thought. What do you think it is? How many factors of 2? 1. That's how you know if it's 0 or 1. We're going to talk about 0 in a minute. I think this is really important. What do I mean by don't work in autopilot? What do I mean by that, Ben? Well, not so much that, but some of us get in the thing like, okay, I know the rule, and you just kind of go, and there's absolutely no brainwaves functioning. You know what I mean? I mean, it's just automatic, and there's nothing wrong with being so good at something that it's automatic. I don't want you in automatic pilot yet. I really want you to think about things. What's the sign going to be? Do I multiply the exponents? Do I add them? I mean, it's confusing at first, and I really want you thinking. It will get automatic, but it's not automatic right away. So I'm going to say stay out of autopilot. That's what I'm talking about. Okay, so we're going to do a few examples here. So we're on page 1. Yeah, see all these examples? So 2 to the 6 times 2 to the 8. Now, I want the answers in terms of exponents. So you can give me the answers in exponents. So what am I going to get here, Claire?
2 to the 14.
2 to the 14. Now, how did you get that?
I added 6 and 8.
Right, the rule says if you're multiplying with the same base, you add the exponents. Now, what if you're like, oh, rule, I can't remember that. So what are we doing here? This is a multiply, right? So are these. They're factors. 6 factors of 2 times 8 factors of 2. How many factors of 2 altogether? That you can almost picture counting them. There's going to be 14 of them. Because there's 6 of them here and 8 of them here. Altogether, there's 14. What about this guy here? Yeah.
3 to the power 7.
Why is it 3 to the power 7?
Because the -3 times -8 is equal to 5 to 3.
Well, this is an odd number.
So that makes it
This one's negative.
and when you multiply with another negative number, it gets positive.
So this is going to be a positive number. Well, let's think. Oh, before we worry about the sign, let's just keep our base the same for now. I like how he's thinking though. I'm going to go back to Gishi's question, which is an awesome question. There's no exponent here, or is there?
It's 0 or 1.
No. How many factors of -3 do I have? One of them. So I've got 7 factors of -3, and I've got another factor of -3. So how many factors of -3 do I have? 8. Now Piyush's point was, oh, you're multiplying a negative 8 times, an even number of times. So you're going to wind up with a positive. So this becomes 3 to the 8. Does that make sense? This is a little bit of a tricky bit. I hope we can get here, but this is a little bit more advanced. Yeah.
What if it wasn't a plus 8?
What if it wasn't? Okay. So if you had -3 to the 7 times -3, what does that mean? It means 3 to the 7 times 3, which would be 3 to the 8. And then I would do a negative times a negative. In this case, it's working out. But you have to think about it. Remember that this number is not necessarily the same as that. This says take -3, and let me make it an even number so you really can see they're not the same. This says -3 as a factor 8 times, which will be a positive number. This says go to 3 to the 8, whatever you get, make it negative. So why is it important that these parentheses are actually here? Because what's my base here? It's not 3, it's -3. So if your base is a negative number, you better put those parentheses around it. Like look at this one. What's the base we're working with? -7. How many factors of -7 do I have?
9.
Well, there's 3 here. How many here?
1.
And 5 here. So I've got 3 plus 1 more plus 1 more. That's a 9. And then let's think about the sign maybe afterwards. A negative number raised to an odd number. So what is that? I'm going to have a negative number. So you can rewrite it like that. Do you see the difference? There's a very subtle difference. So I mean, out of autopilot, you don't have to think about it at first. Yeah.
What's the difference with the numbers in opposite?
Okay, it's how many, remember this is 9 factors of -7? So if you're multiplying something, a negative number 9 times, if you do because 9 is an odd number, -7 times -7 equals -7, right? You're gonna be multiplying these negatives times the negatives times the negatives, you're gonna wind up with a negative. But when it's a positive exponent, you're doing it an even number of times, you wind up with a positive number. Yeah.
So on the number, like the base is in 17, does that mean it has to stay negative?
I would stay until the very end and then start thinking about the sign. I'll have to go there, because it is all about the base, the base, the base. Oh, come on, you know that song.
No trouble.
No trouble. Okay, so what? Yeah, I know stuff. I know
Do you have a
stuff.
math one about that?
Oh, no, that's the best I can do. That's the joke for the day.
We should make a
All right, let's
music
look
video.
and
Last
see.
year's
You can make
goal.
a music video.
We need
Do you get extra credit?
Yeah, but you have to be in it.
No.
You gotta be singing.
I already know my exponents. Okay, what about this one? How many factors of m?
12.
Right, because there's 1 here, 5 here, 6 here. So you're going to add them. Okay, now I'm raising a power to a power. I have 3 to the third. 6 factors of 3 to the third. So what's that going to be? Good. And again, like, oh, that's the multiply. How am I going to remember that? If you can't remember it at first, try expanding. Right? A lot of 3s. Well, that's way too many 3s. 3 factors of 3 times 3 more factors times 3 more factors, right? There's going to be 18 altogether. What about this? How many factors of D? 10. Power to a power multiplied. Now this one, wow, what are we doing with that?
Multiply that in parentheses, then you
Get to 16.
10 more times
346.
Well, without expanding, right, let's leave everything in terms of the exponents. So I don't want you multiplying this and then taking it to the 4th power. It's the 16 to the 4th times 21 to the 4th. And maybe you'll see it a little bit better with this one. So 6 times m times n, right? All that is raised to the 3rd power. How can I maybe, I don't know if it's simplifying it or rewriting it?
That's what it is.
Yeah, to the 3rd power and underneath the next same cube. 6 cubed. So that 3, a lot of people forget to do the number. Y'all listening? Very common to forget to do the number up front. It also is to the 3rd power. That's to the 3rd power, that's to the 3rd power. Yes, sir? You can, do we have to?
No.
You don't have to, it's not wrong if you do. We tend to not do that if you don't have to. It's good, it's not wrong. All right, now this one, what's going on here? So you can almost treat the negative as its own little number if you wanted to. So you can say that's like having a -1 to the 3rd power, and then a 5 to the 3rd power, and then a p to the 3rd power. -1 to the 3rd power, what's that? -1, or just plain old negative. So it's another way of kind of remembering that this whole number will be negative because it's a negative raised to the odd power. If this had been raised to the 4th power, it would be positive, or the 10th power, or the 20th power. An even number would give you a positive number, but this was a little different. Yeah.
Where did you get the -1?
Because that's what this is. A negative 5p is the same as -1 times 5 times p, isn't it?
Yeah.
So some people see it a little bit easier. If you pull that out separately, it helps you maybe see it a little bit easier. Is this a positive or a negative number? Yeah.
So if we do not want to write the negative, if we didn't
You
want to
could
write
have
the
done
negative
this.
one,
-5 to the 3rd power, p to the 3rd power, and then realize, wait a second, that's a negative number to the 3rd power, so the whole thing will be negative. You could do that. This is another way, if you're having a little trouble seeing that. Some people can see it a little bit better if they're only dealing with the negative one. So it's your choice. See if you get the same thing.
Also, would it matter?
the negative,
Yeah.
if we didn't want to write the negative.
Yes,
Would it
but
matter
you
if
can
you
do it like
put a
this.
multiply sign?
I would, this is the answer I would want to see without a times sign. That's what I would want to see this. Like, it's not wrong if you put a times sign, but I'd rather you did, but it's, more grown-up math. Like, big boy, big girl math, we don't do that. All right, now this one's a little different. Is the negative inside?
No.
So we're doing this thing, and then we're going to make it negative. So I'm going to hold that negative over here, and And then what happens here? I get a 2 to the 4th and a q to the 4th. It is going to be a negative number. Why am I not making it positive? Why? Why am I not making it positive, Ben? Why
It's
not?
outside of parentheses.
It's outside. Am I raising this to the 4th power?
No.
Nope. This thing in parentheses is to the 4th power, and this says now make it negative. It will be a negative number. Yes. No, but you do the powers first. Remember, Candace? You do your exponents first, and then you do that. Huh? It's a negative. All right, if this wasn't here, right, it would just be 2 to the 4th, q to the 4th. And now we're saying make that number negative. That's what this means. If it was inside, that would be something else. Yeah, be careful with those negatives. That's what I mean, out of autopilot. Don't go in there. Because you go too fast, you have to think with each and every one. All right, let's look at this guy now. You've got 13 factors of 7 in your numerator, and you've got 8 factors of 7 in your denominator. So how many factors of 7 are we going to have? 13 minus 8. How about 6 factors of x over 2 factors of x? Okay, so it is a subtraction, but I think if you say it that way, it's less memorizing, it's more making sense. I hope. All right, what's going on with this guy? You have 2x to the, this one, okay. 2 to the 3rd times 2 to the 9th times 2 to the 4th. You've got a couple of choices here, and it's all how you see it. I would probably do the numerator first. Well, how many factors of 2 in my numerator? 27? You got 3 factors of 2 and 9 factors of 2. How many factors of 2? 12 of them. So again, I want you out of autopilot. This is not a multiply situation, and that's over 2 to the 4th. Now I've got 12 factors of 2 on the top, 4 factors of 2 on the bottom, so I'll cancel out 4 of them, right? What will be left? 8. Now you could have done this first and say 2 to the 9th over 2 to the 4th is 2 to the 5th, times 2 to the 3rd is 2 to the 8th. Like there can be more than one way to think about that. But I think maybe this is the easiest way. Yeah.
If you had a go number on the top of
What a great question. So what if it just said 2 to the 3rd over 2 to the 4th? What a good question. So that's having like 2 times 2 times 2 over 2 times 2 times 2 times 2, right? 3 of them will cancel out. So what do I have now? I've got a 2 on the bottom, and I just have my placeholder 1 on the top. And we're going to talk a little bit more about what happens when the bottom numbers get called. Well, there is. What's the exponent on that too? A 1. Right? I have 1 factor. We usually don't show that. Yeah? All right. Now this one, a lot of people have trouble with this one. How do you multiply a fraction times a number? You put this over 1, right? Then you multiply the numerators with 1 times y to the 18th. And what's y to the 7th times 1, right? Multiply the denominators. 18 factors of y over 7 factors of y. How many factors of y? 11, right? 18 minus 7. So is that so hard? Not really. You think about it. We're starting to get a little harder now. Oh, what's going on here? Right. Right. And again, there can be multiple ways to approach this. This means the top will be all squared, and so will the bottom. So you're getting 2 squared over x cubed squared, which is x cubed times x cubed times, no, that's it, x cubed times x cubed, right? How many factors of x then? 6. Be careful, right? That's x to the 3rd times x to the 3rd. 3 factors times 3 factors is 6 factors. Excuse me, power 2, power multiply. What's happening in the denominator? That's also getting raised to the 2nd power. 5 squared y to what? Y squared times y squared. And then you look to see, is there anything I can reduce? I don't think there is. If you wanted to say 4x to the 6 over 25y4, that's not wrong. But I'm okay if you leave it like this in terms of exponents, that's okay too. So let's look at this guy now. Either one. You didn't get that?
either one,
These are equivalent. I'm okay with either one. Now remember that have a fraction to a power, it applies to the numerator, applies to the denominator. So the top, everything being cubed, including the number. So 3 cubed over x to the what? 15. Power to a power you multiply because you've got 3 factors of x to the fifth. And what's happening on the bottom? You can leave it like this, or you can call it 27. Either one's okay, because 3 times 3 times 3 is 27. Are we following so far? Yes?
I still have a question on n.
N? Okay, we'll go back up here.
If you had y for the exponent of 6, right? Could you take away 1?
N, you're talking about?
Yeah.
Well, it was y to the 8, 1 over y to the 7 times y to the 18, right? This one?
Yeah.
I put it over 1, so it's y to the 18th over y to the 7. And then you have 18 factors on top, 7 factors on the bottom. 7 get crossed out, so I'm left with 11 of them on top. I'm dividing, so you are subtracting, but we can think about why. Does that make sense?
Yeah.
Okay, she's good. Yeah, now look, it's starting to get hard. No, we can do this. When you see one like this, I like to do this part first. So I'm going to leave the y over 3m to the 4th. Times what? 3 to the 3rd, m to the 6th, n to the 3rd, over n to the 6th. What? What? No?
Oh yeah.
Do we see where I got this bit from?
No.
I took that 3 to the 3rd, m squared cubed, that's a power to a power, multiply the powers, n cubed, over n squared to the 3rd power, that's also n to the 6th. Oh, okay, I'm going to put this all in one big fraction. So, what do you mean what? Multiply 1 times that, 3 cubed, m6, n third, over, multiply the bottom, 3, m to the 4th, n to the 6th. If at all possible, we like to keep the, the common basis above because it's all above. All right, so 3 cubed over 3. Question?
If you would have, so you have 3 and there's a 4, would that be 3 and 4 and then 4?
What? Where is there 3 and 4 and m to the 4?
1 over
1 over 3m to the 4th times this thing, 3 cubed, m to the 6th, n cubed, over n to the 6th. Because that 3 applies to every single thing in here. So power to a power is a multiply. Oh goodness. All right, are we here? Anybody else with me?
I'm right there.
All right, 3 and 3, same power, same base. What's the power on this 3? 1. So 3 cubed over 3 to the 1, 2, 3 squared. Subtract. All right, m to the 6th over m to the 4th.
Oh, we can finish it.
You gotta finish it, yes.
Finish it.
Wait,
How is this?
Well, how's that squared? 3 cubed, 3 factors of 3 over 1 factor of 3. 3 minus 1 is 2. Oh, yeah. What about the m's?
M2.
And here's where it gets tricky. I got more n's on the bottom, right? 6 of them on the bottom, 3 on the top. So I'm going to have them on the bottom. Oh. I think I'm missing something here. I'm missing something. Wait a second. I did something wrong here. I don't know what I did wrong. Let me look again. You're using this wrong. Six is too big. What did I do wrong here? Let me think for a second. Back to that one. We'll go back. I feel like I did something wrong. And it only gets worse. Oh, okay, so I like to get rid of the 2 first. So let's see, that's 3 squared j6 over, now I have to square everything on the bottom, right? 4 squared k10. So far so good, times this k to the 3rd power. Yeah, we don't like it? Uh-oh. What? This is easy. I don't know. We'll find out, won't we?
Oh, that's a J?
That's a J. Okay, so let me put this all together. On the top, I've got a 3 to the 6, j to the 6th, k to the 3rd. I've got a 4 squared. You know what, that's 6? I'm going to write it as 3 times 2. Why am I doing that? Because see that 3. I'm going to put the j first, so it's under that one, and then the k. Oh, slow down.
How did you get? Why did you put 3 times 2?
What? I put 3 times 2 for 6 because I saw that 3 up here. Because I want to be able to reduce that one. Goodness gracious. Now these numbers, let's see what's happening here. What did I do here? So let's see. With the numbers, I can see a 3 squared and a 3. So there's 3 on top, right? And not on the bottom. Because the 3 goes here. And then I've got a 4 squared times a 2 on the bottom. I'm just dealing with numbers. 10. Stay with me. J to the 6 over j squared. How many j's? That's 6 across the top, 2 on the bottom, 2 will cancel out. 4 j's. 3 k's on top and 10 k's on the bottom. That makes 7 k's on the bottom. You have to picture, right? There's 3 k's. And then write 7 k's.
7 Ks.
And you're going to slash them out, right? And you're going to, or 10 k's, and you get left with 7. So let's see, I'm going to just break these numbers to something I can read. 4 squared is 16 times 2. 32 over k7, that's what it is. 3j to the 4th power over 32k to the 7th power. Oh. Well, that's a hard one. You'll get there. But it's just trying to show that to put all this together, this is what it takes. We didn't do this last year. Oh, yes, you did. I guess this is what you did. You blocked it out. Blocked it out. I tell you what, just do, I'm going to have to just do this first row, because I want to get to the next thing. Just do the first row. Or what'd you get for A? 814. What'd you get for B?
5-6.
Now, slow down, right? There's a 1
Why
here.
7?
3 plus 1 plus 2. 6. Now, what about this guy? It's negative 10, right? That's your base. How many factors of negative 10? 2 plus 1 is 3 plus 5 is 8. So it's a negative number raised to the even power. So it's going to be a positive number. Yeah, you were right. And then what happens to this one? Multiply. Because you've got 10 factors of 13 to the 3rd. We can do this part real fast, can't we? What do you get for E?
16.
We were doing E power. I'm doing it. What about this one? You get negative 8 to the 21st power. Odd number, we can make it negative 8 to the 23rd. Now this one, don't be fooled. It's just W plus 8 to the 18th power. You don't, this is a plus, not a multiplier. So this 9 does not apply to both. Only works if that's a times. And this one's 5 to the 6 times 18 to the 6. Good. Yes, and 21 is an odd number, so if you do a negative times a negative times a negative, do that 21 times, you're going to wind up with a negative. Believe me, what is this guy for? Okay, so those are kind of the easy ones. I'm going to leave these for the time being. These ones are a little trickier. I just want to get this little bit of the lesson in. 0 and negative exponents. You ready? Yeah. You ready? Find the quotient. So I'm looking up here. What's our rule? 2 to the 3rd, right? Same base. So you subtract, right? So what do you get? 2. 3 minus 3. Wait a second. Same thing. Wait. Same thing over same thing. What's 5 over 5? 1. What's 100 over 100? 1. What's 2 to the 3rd over 2 to the 3rd? same, right? Is that gonna be 1? But let's use our rule, subtract. The x's. Same thing over same thing is 1, isn't it? But let's use our rule. It says subtract the exponent. So anything to the 0 power, you know what it is? 1. Anything to the 0 power is 1. You could have the most complicated expression in here, raised to the 0 power. You know what you get? 1. Anything to the 0 power is 1. So does that answer your question? Like, is it to the 1 power, to the 0 power? To the 0 power is really the same thing over same thing. It will always be 1. Okay, now negative exponents, okay? This is a case where our rule says subtract, right? 2 minus 4. Now let's think of what this is though. That's 2 times 2 over 2 times 2 times 2 times 2. You agree?
Yeah.
Slash those guys out. What are you getting? 1 over 2 squared. Let's see what this is. According to our rule, that's a 1, right? What's 1 minus 2? What is that? That's 4 over 4 times 4. 1 over 4. What? Okay, well, according to our rule, subtract, right? 2 minus 4. Oh, what is that? That's x times x. X times x times x times x. 1 over x squared. What's happening? 2 to the minus 2 is 1 over 2 squared. 4 over minus 1 is 1 over 4. X to the minus 2 is 1 over x squared. What's going on if you have a power when you have a negative exponent? Yeah, what's going on there, Ryan?
It's a fraction, and that number, that power is the denominator.
This number right here is a fraction. It's 1 over a to the n positive. So I like to think about it this way. See how it's a negative? Negative is sad, right? It's negative sad. You know where it wants to be?
Positive.
It wants to be positive. So if you think about where this lives, think about this as a fraction, right? It's in a numerator. It will be happy in the denominator. What if I have 1 over a to the minus n? Is this a happy little number here?
No.
Where will it be happy? Up top. So if you are in a numerator and you have a negative exponent, you want to be in a denominator as a positive exponent. And if you are in a denominator with a negative exponent, you want to be in a numerator with a positive exponent. What's your round? It does. No, it does. So this is what I just said. A to the 0 is 1. A to the negative n is 1 over a to the n. 1 over a to the minus n is a to the n. So you can kind of move these up and down. It's just you have to change the sign of that exponent. Not a negative number. You will want to say this. This is a negative number. No. This is that. Just because you have a negative exponent, it is not a negative number. Think about, you see negative exponents. Remember, like, 2 times 10 to the minus 3? Remember that?
Yeah.
Right? Scientific notation. And you said, move it to the left, because I'm dividing. This is really 2 times 1 over 10 is positive. It is. Dividing by 10. Dividing by 10. You didn't even know you were doing it. Yes.
What if the equation is already fractions with a negative?
What if I have something 1 over x minus 2 like that?
Yeah. No, we're going to go to the
Both of them?
yeah.
Oh, it's the same thing. Oh, okay. What's minus 2 minus minus 2? Same thing over same thing is 1. As long as it's not equal to 0, right? She's doing the example with the principles. First of all, let's do them in order here. What's 15 to the 0 power? We're doing them in order. I'm going to go to C. Negative 7 raised to the 0 power. All right, what's going on here? Is this a happy being 4 to the minus 3? 1 over 4 to the 3rd power. Now it's happy. Right, positive x positive. I'm going to go to E first. Let me go to this one. 1 over this, okay, is 2 to the minus 3rd. Is that happy in the denominator? No. Just please put me in the numerator. I will be happy with this positive exponent. Okay, let's go to this one. Now you're raising a fraction to an exponent. Becomes 3 to the minus 3 over 2 to the minus 3. So far, so good? apply that exponent to the numerator and the denominator. Is this guy happy?
No.
He'd like to be down there. This one happy? He'd like to be up here. This is 2 to the third over 3 cubed. Whoa! Guy's head explode. Look him. Okay, brains are still in. That's good. That's good. Look at this little innocent thing right here. What's that? And think, no autopilot. 0. No autopilot. What is this telling me, this minus 5? It's 1 over 0 to the 5th power, which is 0 to the 5th power is 0, right? It's 0. Can't do it. You cannot divide by 0. So this is a fraction dividing by 0, which we can't do. That's important. Oh, you still with me? Kind of. A couple more examples here. All right, now listen. The rules are still the same. If you are multiplying same base, you add exponents, right? So what do you get here? Yeah, which is 2. And think what's going on here. This one, that's 13 to the 16 on top. This one says, I'm not happy being on the top. Let's see in the denominator, please. See where that 13 squared is coming from? What about this thing? 6 to the 0, which is 1. This is really a 1 over 6 to the 14. Oh no, what do I do here? 4 to the negative 4. If I want to only use positive exponents, 1 over 4 to the 4th power. What's going on here? Oh. 1 minus 1 minus 2.
That's positive
5 to the, but you subtract the exponents.
Oh yeah.
Yeah, but I'm subtracting because I'm dividing. And if I only want positive exponent, that's that. This is so confusing. Alright, same base. Let's add exponents. 5 plus a negative 5. Oh, that whole thing is 1. Right, you look at that, you're like, that's 1? Yes. So they get a little bit confusing, but use those rules, you'll be okay. Let's see where we are here. Oh, we got algebraics. Oh no. Same thing. Okay, what's this one?
Is 2 to the 3rd,
Yeah.
x to the 3rd,
Yeah.
and then 1 over y to
Right, y to the negative 15. If I only want to express this with positive exponents, it's not so bad. Got it? Take it one at a time. It looks like you're a genius. You show this to your folks, they'll be like, wow. But listen, it's not so bad. Just take it one piece at a time. What's going on here? So kind of clear out those parentheses. 2 to the minus 2, x to the minus 2, y to the 5th, right? That's the numerator? Yeah? And then this is the bottom. Let's see here. The numbers can be a little bit confusing. I'll go back to the numbers. But I'm just put the 2 squared on the bottom. Right? Because now it's happy. Now x to the minus 2 over x squared. Negative 2 minus 2. X to the minus 4. Y to the 5th over y squared. Wait a second, he's unhappy, isn't he? He would like to go down there. So what do I have here? Y to the 3rd over negative 2 squared. That's 4 times 4. That looks like a 16. Can you do it? I think we did. Here it is. This one, 3 cubed, m to the negative 6, n to the 9. Now this guy would rather be in a denominator because I'm happy. And if you really want to make that a 27, but I'm okay if you leave it like this. Are you with me? You're not with me. You shut me off already. Who's here? Why are there only 4 people here? Oh, Sherry's here. I'm here. Okay. All right, I'm gonna this one. You know what? I'm just gonna. I have mercy. I'm gonna leave you with that one. I want you to try. We have about 5 minutes left. So first thing you might want to kind of work on are finishing off some of these guys. And I wouldn't do all the really hard ones. Maybe just do like a row like this. I, J, K, L. And then maybe work on some of these with the negatives. Good comment. Here. And I'm gonna put up answers. So if you do want to check this at home, you can. are negative exponents. I am gonna put up the ones for the other ones as well. Just so that you have them on the recording so you can review them. And while you're working on these, I'm gonna hand out some homework, okay? We'll do the rest of this lesson next class.
Test. What about the test?
What about the test? I don't think we have time to do the next.